I'll start the recording. So with chapter 5, let's see. Let me go back here to chapter 5. We did talk about the problem that was worked on here, which is essentially using data provided in the problem to solve for atomic mass. This is one of those learning goals you want to know for your homework. It is in your homework. There are actually 2 questions about this in your homework. And then, of course, you want to know this for the exam. Okay, so you have this table right here, and in this table you're provided with a lot of information. And let me see, I'm going to leave this right here, the chat box here, message box. If you want to talk directly into the mic, that works. If you want to just message, that works too. Okay, so in this table here, we're provided information about this different isotopes. So real quick, since I didn't meet with you guys on Tuesday and last week, I'm going to make sure we're on the same page. So isotopes, okay, here's some feedback. Yeah, isotopes are elements from the same, atoms from the same element that happen to have different weights. Okay, so we'll go through a list of the isotopes we have here. This is a whole table of isotopes. Now, this table doesn't show all the isotopes we have around. It just shows the most abundant ones. Abundant just means that you have a lot available, so they can be detected easily. With the hydrogen here, it's just showing us 2 hydrogen isotopes. There are actually 3, but only 2 are shown here. So we're shown one that has a 99.9% abundance. The other one has 0.01. And of the dominant ones they show you, if you add up the percentage abundance, it usually adds up to 100. Meaning the other ones that they haven't written here are so insignificant in their amount, it's okay for us to kind of ignore them in trying to figure out the molar mass, okay, or the atomic mass. So you add these 2, you get 100. Looking at helium here, they gave us 2 isotopes of helium, the first and the second one. Once again, that just means that, say you were asked to go out there and find a sample of helium. This isotopic chart tells you which of the isotopes you should see more of, and then what percent. So based on the helium we see here, if you were out there and you were asked to go and find a natural sample, because these are natural isotopes, a natural sample of helium, we're told from this table, you will find more of helium with a mass of 4 than you would helium with a mass of 3. How much more? You will find 99.999% more helium 4 than you would helium that has a mass of 3. The one with the mass of 3 is so small in the abundance that we can almost ignore it, right? So let me move to a list here that's more than 2 isotopes. We have sulfur. Sulfur actually has, they listed 4 isotopes. So if you're going out there to study sulfur in nature, you should expect to find 4 different types of sulfur atoms. Okay? Now, they will have different masses. The most heaviest of the sulfur atoms will be the one that has a mass of about 35.96 because it has the heaviest atomic mass unit, right? The mass. What about the abundance? Okay, it just so happens the lightest sulfur has the greatest abundance. So the sulfur that is approximately 32 atomic mass units is about 94.9% abundance. So if you go out there, once again, you're looking for sulfur, you will find this the most, followed by this one here. Then this will be the third amount, and then you will rarely detect that one because the amount is so little. Okay, so what I did from here was I used these numbers provided here to figure out the atomic mass unit for sulfur. And the atomic mass unit will be the same thing as the atomic mass that we see in the periodic table. Okay? So what I'm going to do here is I worked it out over here, but I'm going to work it out again so we can see how this works out. I provided this formula on Tuesday. And on Tuesday, I talked about the formula required to calculate the relative atomic mass. And this mass is essentially the mass posted in the periodic table. The one that we call the atomic mass for the element. Okay? So to figure that out, the way scientists figured this number out, they started with the table provided or the experimental results. They wrote the percentage, which is provided, the abundance, over 100, and then multiplied this by the atomic mass unit, or in your case, your PowerPoint slide calls the symbol U, atomic mass unit, or just U. And you set up one of these for every isotope you have. If you have one isotope, you just set up one of it. If you have two, you set up a second one right here. If you have three, you set up three of these. So one for every isotope provided, okay? So based on what we were working on, sulfur has how many? 4. So let me go ahead and copy this, because it's hard to go back and forth and back and forth. I'll copy this, and I'll copy the abundances, so I can actually work this out. Okay, let me see. I'll copy this, and I'll write this up here, paste image. Okay, so having this, I'm going to go ahead and set up my calculation to figure out the relative atomic mass. Okay, so the atomic mass of sulfur is equal to, I start with the first one. This right here is my AMU, also written as U, so I'll start with that, and this is my percent abundance. Now I took this out of the table, so I'm trying to write my labels here so I know what is what. For my first sulfur isotope, I will start with my percent, right? 94.93 over 100 times this number right here. This is a large number, so I'm going to just write 3 numbers after the decimal. 31.972. And I'll use the symbol U since your book uses U. Next one. I'm done with this. The next one is 0.76 over 100 times 32.971. Oops, I forgot the symbol U. The next one. Okay, as I'm writing, I can tell that I already wrote too big. It's a struggle. I'm so used to writing big on the board so everybody can see. Now I have to write small because I don't have a lot of space. That's okay. So I'm done with this one. Then my next one is 4.29 over 100 times 33.96. I'm going to round this up right here. 8U plus 0.02 over 100 times 35.967 U. Ooh, almost ran out of space. Okay, barely made it. Okay, since I had 4 isotopes, as you can see, 4 of these, I had to do 4 setups. Now I'm going to just multiply, add all these numbers, and then see how the atomic mass for sulfur that I just figured out compares to the one in the periodic table. And I have my periodic table right here, so I'm going to compare. Okay, so to plug this in the calculator, let me see if I can do it all in one swoop. Open parentheses, 94.93. I'm going to divide and I'm going to multiply. Divided by 100 and then times 31.972. Close parentheses. And I'm going to add. Actually, let me just do it this way to make it simpler. That way, if I make a mistake, I don't have to do everything over again. So 30.351 U plus 0.76 divided by 100 times 32.971. This is 0.251 U plus, so I'm going to work this one next. 4.29 divided by 100 times 33.968. I have 1.457 U. And then finally, 0.02 divided by 100 times 35.967. I have 0.0 719 U. Okay, so now I'm going to add all of these, and my goal is to get the mass that we see in the periodic table. So I'm going to draw the atomic symbol so y'all can see the mass I get, how that compares to the periodic table mass. So I'm adding the last number to 1.457. I'm kind of working from right to left, plus 0.251 plus 30.351. Okay, I end up with 32.066 U. Okay, this is my sulfur atomic mass. So let me draw the sulfur atomic symbol that I have here. In my periodic table, it looks like this. I have the symbol S. I have 16 for the atomic number, or the number of protons. Below that, I have 32.066. Look at that. Okay, so essentially the number that we calculate atomic mass unit is the number that they have here. Now, if you want to get the number they have in the periodic table, you have to use all the abundant isotopes. Okay, so the takeaway from this is the masses that we see in the periodic table are not the masses of just one isotope or one atom, but this is essentially the average. And not just any average, it's a weighted average of all the most abundant atoms of sulfur. Okay, so we took all the atoms that are abundant enough to be weighed, to be detected, and we averaged them out. It wasn't a regular math average where you add them all up and each one weighs equal amount. We did a weighted average. That means the one that had a higher percent abundance contributed the most, right? So look right here. My final answer is 32.066. If you look at this stage right here, the one that had the highest abundance contributed the most to the final mass. And for that reason, the final average mass seems to be a lot closer to this one here. So this one here contributes the most. So you want to be aware of that too. The isotope with the highest percent abundance, or the percent present, contributes the most. So the other way I look at this is kind of like in your assignments that you complete to get a grade for in the class. Your different assignments have different points and different percentages, right? So if you were to group them together, the assignment that will contribute the most to your overall grade will be the exam. So you could argue, or you could say your exam contributes the most. For that reason, your exam has the highest percent abundance in your final grade in the class. Okay, and then the one that contributes the least, you can say, well, let me see, of all the assignments you did, maybe completing that safety sheet in the end was what, 20 points? Submitting that, signing and submitting that. So you could say that's one of the least abundant assignments, right? Yeah, you got points for it, but in the big picture, it wasn't that much. Okay, so yeah, they worked this out, and then, well, based on how they rounded it up, they got 32.065. Anyway, so make sure you understand that. It's important. I think the two questions in your homework that cover that. In the end, Mendeleev and Meyer were the two scientists that studied the elements a lot. And then Mendeleev was addicted to a game that was similar to solitaire. So the game that he was addicted to helped him to visualize the behavior or the connection between the elements. He wondered, he hypothesized, what if the way the elements or the atoms of the elements are related to each other the way the cards in the card deck are related to each other? You know how you have the different suits, I'm like, and I forgot. I don't really play cards that much. The one that looks like a flower, the hearts, spades. Anyway, they have a relationship, right? You have the A and goes all the way to Oh my goodness. I shouldn't even use that analogy because I'm really, really bad at cards. But you understand how they relate to each other. So he figured if there is a relationship between the elements, then I can actually categorize them and I can sort them out based on what they have in common. Just like cards have those symbols in common, maybe the elements have certain behaviors in common. So what he did was he arranged the elements according to similar properties. And the ones that were very similar, he placed in the same column, and that would be vertical columns like this. So remember, he's sorting these out. It would be like if you were asked to sort out M&Ms based on this on the same color, you would sort out all the blues together, all the yellows together, and things like that. So he's sorting them out, and as he sorted them out, he started to see a pattern. So apparently, when you're playing card games, recognizing patterns is part of the skill set you have to know, right? Now he's relating that skill set he learned from card games to the chemicals. As he was arranging them, he found that there's certain properties in the elements that were kind of repeating, kind of like a deja vu at a regular interval. So after two elements, he would see a certain behavior, such as a behavior of an element that's more like a metal. After three more, he saw a behavior where the element was more like a gas. And this pattern repeated over and over again. So there was a periodic repeating of the pattern. Okay. Now, his results, the arrangement he had was not perfect. Of the elements, it wasn't perfect. Okay. Because what he did was he arranged the elements according to atomic mass. So after we learn about figuring out the atomic mass, he arranged elements according to atomic mass. Well, because there were errors in figuring out the atomic mass or the atomic weight, in 1869, scientists decided that they should not use atomic weights or atomic masses to sort out these elements because they were bringing about errors. They decided to move on to atomic number. So remember, in sulfur, we're talking about the atomic number, this number right here. So scientists use atomic number for what we call the modern periodic table to sort out elements and to arrange them versus the atomic mass. Okay, so Mendeleev used the atomic mass to sort out the elements. Scientists later on decided no, the better way to sort it out is atomic number, because atomic numbers do not change. They're kind of like social security numbers for the element, so they can't change. So it's a more reliable way to judge the element and to sort them out. If the atomic mass changes slightly because of the number of neutrons or something, that changes where you place the element. Okay, so a more reliable number was the atomic number. So our quote unquote modern periodic table is sorted according to atomic number. So here we have a picture of the periodic table. Just FYI, be aware that when you go out there and you're looking at different periodic table, there's so many different ones. I mean, so many different ones. They're so different because periodic table are put together for different purposes. The periodic tables are tools, kind of like a ruler is a tool, but a ruler measures something. This is a tool to provide the scientists with information. So depending on what periodic table you're looking for, you would have to be specific. If you're going online to find one, you have to be specific what information you want it to provide you with. Okay, so looking over here, we have periodic table showing you the elements. Here they're categorized. You see the red zigzag called the staircase? This separates one side of the periodic table with the other. The side on the right here tends to mostly have nonmetals. The side on the left, this huge side here, has metals. Now you would think that with all these metals we have in life, we have a lot of metals, right? But because we have living things, and living things are made up of carbon, we call them organic, even though we have fewer types of nonmetals, we have more abundant nonmetals compared to metals, okay, because of living things. So just in case you're wondering. So as we've looked at that, we want to make sure we know about this. You want to know what the atomic number is in the periodic table for all the symbols presented. The chemical symbol, recognize that, know the names of the elements. So I'll say here, know names of element. Remember, we talked about this before, but I want to go ahead and review that. For the atomic mass, to get the mass, you take the number of protons, or the number up here, plus the number of neutrons. Okay, so the mass will always be bigger than the atomic number. Atomic number is also equal to number of protons. Right. So atomic number will always be less. And remember, that's kind of like the social. It's the number that doesn't change. If the number changes, then the element they're referring to has changed also. Okay? So recognize the symbols. Now for the periodic table, we want to also realize how they have arranged these elements. If you're looking at the periodic table from left to right, we have horizontal rows, and these rows are called periods. Okay, so when I think about it, we don't go to movies much anymore this year, right? Or last year, I know. If you're going to a movie and trying to buy your seat online, you have to select the right row where you want to sit. You want to make sure you're comfortable, you're not hurting your neck. So you want to be you want to recognize those rows. So those rows in the theater are like periods. Okay, so you have periods, horizontal rows from left to right. And we want to define these terms because later on we're going to be relating the elements across the period or across the row. And these are numbered from top to bottom in the periodic table. We're told they vary in length. Some periods are very long, some periods are very short. Okay, so going back to our periodic table, let me erase all the scribble stuff I wrote here so I can show you the period. So across from here all the way to here, this is period 1, this right here, period 2, this right here, period 3, and you can see that, right? You have period 4 and then period 5. Okay? So I noticed that some of your questions requires you to combine the period number and the group number to identify an element. Okay, so let me do a simple one like oxygen. You see where oxygen is. So let me use a different color. Let me use blue. To remember the group number. They gave you the group number here, right? I'll write this a little bit larger. Like you have 1A, 2A. Remember, the group numbers are in blue. So kind of like a coordinate system, use the group number and the period number to identify the element that intersects when you get the group number and the period number at that intersection. So you have 1A, 2A, we got 3A, we got 4A, 5A, 6A, 7A, 8A. So if I'm asking you for the period and group number where oxygen is right there. Maybe that's in the way. Then you can see oxygen is in period 3 and then group 6A, right? So there's oxygen. So what I'm going to do while I'm here, let me detour a little bit to your homework so we can see an example of this kind of question and how that works. Oh, but before I do that, just realize once again, for the group number chemical family here, group of the vertical rows, they're called chemical family because just like you and your family members have similarities that make you a family, if somebody sees you guys all together in a picture, they can say, oh yeah, I can tell you all of the family, them genes are strong, right? Your genes are strong. Maybe you all have the same nose, the same ears, something distinct. Well, the chemical family is called a family because there's certain things about them that are similar. What is similar here are the properties. So even though these elements are not people, the people studying them are people, and we humans have a habit, right, of making other creatures or chemicals human-like. We're trying to relate to the chemicals in the way that makes sense to us. Science is really about us, right? So we give these chemicals that are entities human behavior. All of a sudden they're family and they're relatives, right? So they have similar properties, and we place them in vertical columns called a group. You can call them a family or a group. So we know if the properties make them family members, they're going to behave in a very similar way, right? So groups are identified by two rows of numbers across the top of the periodic table. So the two different rows, and I'll show you how that looks. The elements can be from one of the A groups. So the numbers I show you here, there are two different sets of numbers, and depending on the questions and who wrote them, you see right here, I use the A portion, right? The 1A, the 2A. You also have the bottom number that's also used. Apparently, scientists decided the 1A and 2A was not good enough, so they came up with new numbers, trying to keep these things fresh. So you can be told group 1 is either group 1A or just group 1, okay? And then with the one that goes from 1 to, I'm going to use a different color so y'all can see. It goes from 1 here to here. And before we skipped over this block completely. So just so you can see, let me erase that part here. If you're going with the regular numbers with no letters, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we got 13. So what used to be group 3A is now called 13. Now, I am not big on memorizing. My brain is just not wired to memorize things. And I was like, oh no, now I have to memorize another group number for 3A. Look at it this way. When you get to 3A, if you're more familiar with 3A, for the new numbering system, just add a 1 in front of the 3 and lose the A. And if you're used to 4A, add a 1 in front of the 4 and then lose the A. So you're not having to memorize a lot, because I am not very good at memorizing. So you have 5A, once again, put a 1 in front of the 5 and lose the A. So 6A, 7A. So once I realized this, I was like, okay, I can do this. I can do this, 8A, right? So 1, 6, 1, 7, 1, 8. So they can give you the group numbers either by the old school way, which is the ones with the A, or the ones with the numbers only. So you want to be familiar with both of them. Now, in the world of science, I gotta tell you, what I really love about science, it doesn't change that much, especially chemistry. What they call new is 100 years old. I'm like, I can do that. I can do that. It takes a long time for changes in chemistry to be accepted. They have to be vetted a lot. Okay. So let's see, where are we? Yeah, so we've gotten to this. And as I mentioned, the numbers, when they have the whole numbers without the letters, remember that includes what is called the transition elements, the ones that we skipped over previously. Transition elements, transition metals, and that's when these are numbered. They used to be formerly known as the B group. These are numbered 3 to 12, and then we pick up where we left off from, the A group, and then continue 13, 14, 15, all the way to 18. So these are called transition metals. So we are referring to this right here. This group right here that we left before is transition. Okay, so I want to make sure we're properly prepped before we do the homework, or we're not doing the whole homework, we're just kind of working on a couple of them. Once again, I showed you the metals, the non-metals. So the one thing I haven't mentioned is the metalloids. So with the metalloids, essentially, the metalloids are the elements on the border. Now, remember, I like to bring in, I figured if Mendeleev, the scientist, right, who gets credit in the book, could bring in his card game that he was addicted to help him out with chemistry, I can bring in my life, right? So when people tend to live in the border of maybe a city or a country or something, they tend to culturally assimilate with those on the other side of the border. If you've ever traveled to see that, the culture tends to kind of blend in, kind of like a tie-dye of culture, right? It blends in, and you see some of the elements of the culture across the border where you are. So border people tend to do that. Well, it just so happens elements do the same thing. The elements very close to the border of the metals and non-metals tend to have both properties, okay? So these silicon and stuff, these are called metalloids. Oh, I didn't write that properly. It looks like metabids. Let me write better. Metalloids. Okay? And they're called metalloids because they have properties of both sides. They have both metallic and non-metallic behavior. Okay? So the one that we're most familiar with that we should be able to relate to is silicon. Okay. Now in class, I usually ask, what is silicon known for? And back in the days, I'll get the answer, semiconductors. And I'm like, yes, it's used in the semiconductor industry. It helped to revolutionize the cell phones. We went from phones stuck to the wall where we couldn't move around to flip phones to now, touch screen phones and stuff like that. So yes, yay to silicon. Now, when I ask this question, I get a different answer. I'll just leave it as that. When I first got a different answer, I was like, I can see where you're coming from. I can see where you're coming from. Yeah. Yeah, silicon used to be known for the semiconductor industry that revolutionized the cell phone, right? Making it what it is today. Okay, so once again, before we will go to the homework, but before we get to there, they list the elements here that are on the stair-step line. So they're right here. You have boron, silicon, germanium, acetine, antimony, tellurium. So these are the elements that tend to be very close to that border that have both behaviors. And so these are very precious to scientists, to industry. I was teaching a chemistry class for engineers, and I was learning so much from that because, there's a chemistry theory, and then there's a chemistry that applies to businesses, and that's a whole different area. And I'm not as familiar with that because I don't work in the industry. But I was reading about how precious metals were and how important metals like gold and platinum was, and I'm like, and here we are walking around with gold and platinum on our fingers, right? Or yeah, and meanwhile the industry is saying this is so important because we needed to design all this technology, and I'm like, it's just so interesting. At least to me it is interesting. But semiconductor behavior is very important because there's certain setup in a machine where the scientist or the engineer needs the element to have both properties, right? So these become very, very valuable. Okay, moving on. It says right here, list the atomic number, chemical symbol, and atomic mass of the third period element in group 6A. Third period. Okay, we can do that. I know the answer is right here, but the goal is for us to learn this. So let me go back here. We'll work on a homework problem where we can't see the answer ahead of time. So period 3. So I got to move down 3 spaces, right? 1, 2, 3. So period 3 is somewhere here. And they said group 6A. So let me zoom in. Y'all can see 6A is right here. So I draw down here. And the point of intersection is right where sulfur is. So sulfur makes it again. So you can pretty much draw this symbol right here. They asked for the symbol. That's the symbol, the chemical symbol. You have atomic number of 6, mass number 32.06. If they ask for the mass number, I guess you can put that one too. Just depends on what they're asking you to provide. The purpose of that is to make sure you know how to read the period, right? And the group number. Yeah, so it said, let's see, chemical symbol. We got that sulfur, atomic number 1632.066. Yeah, atomic mass. Why is the atomic mass missing here? Yeah, so this is a symbol, element sulfur, symbol S, atomic number 16, mass number that. Do they continue on the next page? I guess. Okay, so before, this is pretty much the last slide. Let me go ahead and go over to the homework, just a couple. So I would suggest when you're doing your homework in chemistry, don't study the whole chapter. Yeah, you heard me right. Don't study the whole chapter before you do the homework. Only do that if you've had a strong background in chemistry in high school. If you're still learning this for the first time, pick maybe like 2 sections in the chapter. Study those very well. Make sure you really understand. I've done lectures and videos for going over the chapter. Like, watch the video to a certain point. I mean, you guys have the power to press stop. I want to use the word rewind, scroll back. When I say rewind, I mean scroll back. So stop, rewind, watch it over and over and over again until you get it. And then get to a stopping point. Then go to your homework and just do those problems to make sure you understand them, like I'm doing right now, okay? Because if you do the whole chapter, it's very easy to miss the details. And then chemistry is in the details. So if you miss it, then you're kind of just lost unnecessarily. And technique really matters in chemistry. So I did it wrong until I started doing it right. And then eventually I figured it out. So I had a student telling me, I read the whole chapter. I'm like, really? Wow. And they're like, yeah. And I told them, I don't even read the whole chapter. They was very surprised. I said, no, it's too much information. If I read the whole chapter, at some point my brain begins to shut off. It goes into what I call power save mode. And then I start to skip the details, and I'm just trying to fulfill whatever the task is, which is not really learn anything. So I don't do that. I don't read the whole chapter. I read what I need to know at that point and then cover that. Okay, I'm going to look at this as a student. Hopefully it doesn't count against me. Okay. Oh, look at that. Okay, it says here, refer to a periodic table. I have mine right here. Oh, you know what I realized? Let me see. I used to have a periodic table on my iPad. I'm realizing I probably should have one all the time. It might be easier for me. Yeah, give me just a moment. Let me find the periodic table here. Then that will help me out. It's so hard to find stuff online these days because they have so many things on there. Let's see. I want the atomic number, and I also want the mass number. So I'm going to say periodic table mass number and see what I get out there. Oh. This periodic table is so-so. It's okay. Let me see. I guess it will work. Okay, so let me pull my periodic table that I just got right here. It's not the best, but I think it will work. Okay, how do I minimize this without deleting it? I know they have references here. Use the reference. Okay, anyway, I'll have this right here for me. So as I need it, I'll refer to this. Okay, refer to the periodic table. I have it right here. Give the symbol for an element that is a transition metal in the fourth period. So remember, oh, they have the numbers here. These are my periods. 1, 2, 3, 4, 5, 6, 7. So transition metal starts from scandium here, 21, all the way to zinc, to actinium, all the way down here. These are also transition, right? And then, so this block here, this block from SC to ZN, AC to CN, and then includes cerium all the way down here. So let me see if I can move that in the corner somewhere. Nope. Okay. Hopefully it's kind of out of the way. Okay. So the set fourth period, 1, 2, 3, 4. A transition metal in the fourth period. Wow, that could be any of these. Really? Any of them? Okay. Let me try with SC. SC. A metal in the third period. So what happened to my... A metal in the third period. So once again, that's so generic. 1, 2, 3. These are metals. Remember the zigzag was somewhere here between boron and aluminum, and it went all the way down here. So the metal is any of the symbols in period 3. Period 3, you can write either sodium or magnesium, that's a metal, or even aluminum. So I guess I'll write sodium. Let's see if that works. Okay. A nonmetal in group 6A or 7A with atomic number. Z is a symbol for atomic number. So this is like shorthand, like LOL, right? So a nonmetal in group 6A or 7A with atomic number less than 40. Wow. Okay. I'm saying wow because this question is somewhat vague, so that could be any of those elements, right? Non-metal is something on the right of that zigzag, so somewhere here. It has to be group 6A. This is 16 is 6A, right? Or 7A. The atomic number less than 40. I'll go with oxygen. Okay. Let's see if this works. Just because I'm assigning you homework doesn't mean I know the answers because I have to actually work it out, right? Okay, a main group metal in the 6th period. Okay, so it has to be a metal and it has to be main. Main means group A, okay? So let me find my periodic table. Group A is essentially group 1, group 2, skip over 13, group 13 all the way to group 18. Those are main group metals or main group elements, sorry. So we're looking for a main group metal in the 6th period. Let me find the 6th period first. 1, 2, 3, 4, 5, 6. This is a cross like that. And then they want a main group metal. So I'll put CS and see how that works. For the symbol, I don't know if they just want the letter or more than that. So I'll write it like this, okay? They might not want that. Oh, that's all they wanted? Okay. As I said, I don't necessarily have the answers to this. Plus, they change the questions a little bit each time. So when I'm working on it, I'm not sure what they want. The symbol theoretically is the letters, but some people will add more to the chemical symbol than that. But apparently, that's what they wanted. Okay, let me see. Yeah, this is what I was looking for right here. What is the symbol for an element that is in group 6A in period 4? This is more like it. That one was just too vague. I mean, we still got it right, but okay. Group 6A, they just said element, right? 6A period 4. So 6A goes with 16, right? The one they both have 6 right here, 6A. And then period 4. Period 4 is 1, 2, 3, 4. So go across and then stop at 6A right here. That should be what? Selenium? SE? Let's try that. SE. I'm only going to do one for this. Any questions? Okay. I'm only going to do one. Oh, come on. They want me to do all of them? Okay. They won't even give me the satisfaction of giving me an answer for that one. Okay. Let's go through the other ones quickly. Group 4A. So that's the one with the 4. This one here. And then period. Yeah, period 6 this time. So 1, 2, 3, 4, 5, 6. Period 6. Oops. Period 6, group 4A. Where is 4A? Right here. That would be lead, right? Period 6, group 4A. At least that's what I see. So PB. Next one. Group 7B, period 4. Period 4. 1, 2, 3, 4. Across, go all the way to 7B. Oh, 7B, not A. Ooh, that was a close one. So for 7B, I need to, because it says B, not A, right? I was going to go to 7A. 7A is bromine. It says 7B. So let me see. 1, 2, 3, 4. This is 4 across. 7B, you have to have a periodic table for that. 7B is this one here, 7B. This group right here is B, right? So manganese. Okay. Let's see if that one works. What is the symbol for the element that is in group 2A and period 6? So let's see. Let's find 2A. We're back to A. 1, 2. Oh, sorry. Period 6 first, then 2A. Okay. 1, 2, 3, 4, 5, 6. Period 6, group 2A. This is 2A. So barium. Okay, let's try. Yeah, that can be a little confusing. Just want to be careful about that. Okay, let's see how that works out. Yay. Okay. So that looked good, right? So of course, I won't work the rest of them. Y'all can go through these and work it out. They tell you how many electrons. I already recorded the video for how to figure out the rest of these out. This chapter is really not that bad. The one thing I would say, please notice that the homework problems are, it's kind of the way I assigned them. I have a buffet of questions. Okay, the questions are already preset by the author and the, yeah, by the author. So if there's some questions I would like to ask, I don't get to ask those. So the best way to make sure you're comprehensively prepared for the exam, go over what I cover in the PowerPoint, because in the PowerPoint I have an idea. So I'll go over certain things a lot. I will emphasize certain things. I'll tell you, make sure you know this. So please watch the videos that I do have on there. Once again, I do emphasize what you need to know. Okay. Yeah. So I did talk about a gold foil experiment because somebody asked me this on Tuesday. I'm not going to go over that again, but I want to move on to chapter 11 because that's the one that requires extra time. Okay. But before I do that, does anybody have any questions? Okay. So since this is the last part of chapter 5, I'm going to stop right here and do a separate recording for chapter 11.